All right, guys, we're going to do, this is basically review parallelograms and triangles, the area. So it's going to go pretty quickly, so make sure you're pausing. First things first, our area of parallelogram is base times height. If you think about it, we've used that for rectangles. And, well, we learned a couple units ago, rectangle is a parallelogram. So we're still using this base times height. We're taking it up a notch, though, and you're going to have to use some of our geometric knowledge that we've learned this year to find some extra stuff. The first thing I want you to do right here at between area parallelogram and the instructions for number 1, this is extremely important so that you get the correct answer rounded. While we're working through these, we're going to round to the nearest thousandths. Remember, there are 3 zeros and thousands, so we will have 3 numbers. We're going to round every single thing, unless we have like a radical or pi, we're going to round everything to the nearest thousandths until the end. At the very end is when we'll look at the instructions and say, okay, what do they want us to find? So for the following problems, we're going to find the perimeter and the area of these, and we're going to round to the nearest tenth at the end. All right? So first things first. We can actually go ahead and find our area right off the bat. If we take a look here, our base is going to be a total of 18. So we have our base and we have our height. So for area, we just have base times height. We substitute in. I've got 18 times 16. You can plug this all in the calculator. If you put the in the Desmos, that A over B button gives you a fraction function. You can plug 18 times 6 up top, and sorry, we're not dividing. I'm already jumping a triangle. Sorry, guys. So we have our 18 times 16. That's it. Our area is going to come out to 288 feet squared. Okay. To find our perimeter, though, we need to remember something. And I was really proud of my classes because they realized, hey, how many sides do we have information on? How many sides are labeled do we have the measurement for? And they were telling me 2. Because we remembered, in a parallelogram, your opposite sides are congruent. So then we do have we have one pair of congruent sides. We do need to find the other. So how we're going to do that is we're going to use this right triangle because we have our 2 legs, 16 and 8. So we're going to go off to the side, and we are looking for a hypotenuse here. So we're going to have c squared is equal to that 8 squared plus 16 squared. So c squared in class, I showed kind of a shortcut. You can actually just take the square root of 8 squared plus 16 squared. But I'll go ahead, because not everybody likes that, we'll go ahead and go through each step. 8 squared gives us 64 plus 256. Add those together, we're going to get 320. When we square root this to get rid of the exponent here, we're going to find out that c, we are going to have to round here. We're going to get 17 and 889 thousandths. Be careful, there are 3 eighths, but after that third 8 is a 5. The fourth number is a 5, tell us to bump that up. So now over here we have 17 889 thousandths. So now we can find our perimeter. Now, whenever we have the parallelograms, whenever we have opposite sides are congruent, we don't need to add. You won't have to say 18 plus 18 plus. Remember, we have 2 18s plus we have 2 17 and 889 thousandths. Okay, so we add these. We can multiply them first. We get 36 plus 35 and 778 thousandths. Add those together. Our total perimeter, now we're at the end, so we're going to round to the nearest tenth. We're going to have 71 and 8/10 feet. Labeling the units isn't too big a deal. We want you more understanding the math. Okay? On number 2, we're going to take a different look at this. We do not have our base. We do not have our height, so we cannot find our area, but take a look at this. We can find our perimeter right away. Your perimeter is just going to be 4 times that side length because we do have 4 congruent sides. So all we do is we plug in 24. And again, all of this should be review, especially perimeter. And we're going to wind up with 96 inches. I'll probably drop off the units in a little bit. Now to find our to find our height, we can use two different methods. We see we have a 60 degrees over here. We need to remember properties of parallelograms, your opposite angles are congruent. So we have a 60-degree measurement up here. So we have a 30, 60, 90 triangle. So you can either look at it as your 30, 60, 90 triangle. Sorry, I'm saying 30 and trying to write 60 at the same time. They're your 30, 60, 90 triangle, or you can also use trigonometry. Okay? So we already know that right here, this side is also 24. So we have our hypotenuse. We're looking for the height. Okay? So you can use trigonometry, and you could say, you can use the 60 degrees and say, okay, we have our opposite over hypotenuse, and you can use sine. That one you will have to round to the nearest thousandth, and you'll have more numbers. Let's take a look at it with our 30, 60, 90. Across from our 30 degrees is A. Across from our 60 is A square root of 3. Across from our 90 is 2A. We're given 2A, which tells us 2A is 24. A is going to equal 12. We don't want A, but we need A square root of 3, our height. So all we do is we substitute in for A, and we get 12 square root of 3. Okay? We want to keep that radical there. If we're using a radical, keep it as a radical until the very end. Okay? Don't calculate that and get a decimal, because then you just got to write more. That being said, we'll take our base times our height. Our base down here of 24. And our height, which we found out right here, okay, our height was 12 square root of 3. So we just plug those into the calculator, and since we are going to, this is our final answer, we will round to the nearest tenth. You should get 498 and 8 tenths. Okay, and that'll be inches squared, or squared inches. When I get everything set up, I want you guys to make sure that you are doing these calculations on your own. Okay, just pause it real quick, do the calculations, and resume. Number 3, hands down, everybody should be able to do. This goes back to, without the decimal, this would go back to 5th grade. Okay, when you see here that we do have a square. The reason I know is it's a parallelogram with all 4 congruent sides and a 90-degree angle. I've proved it's a square. Okay, so for our perimeter, all we need to do is just like we did in number 2, all 4 sides are the same, just do 4 times your side length. So 4 times 1.6. Calculate that on your own, guys. You can do this. And then resume. Don't take long to push that pause button. We're going to wind up with 6.4. For your area, we can do base times height, or since we do have a square, another way to look at it is you take your side length and you square it. Okay? So I'm going to take that 1.6 side length, and I'm going to square it, round it to the nearest tenth, because this is our final answer. We're going to get 2.6. Number 4, we're skipping. Okay, when we solve it, it ends up above what we've done. So it goes way back to a bunch of algebra stuff that we haven't done, and we're not going to spend time on it right now. So let's go ahead and take a look at the triangle. Again, it's all review. The only difference here is that we're going to have to do some other geometry stuff to figure out side lengths. Here we have 1/2 of base times height, but most of us generally like to look at it as base times height divided by 2. That's the formula I will be using for area. All right? We will be finding perimeter and area around the nearest tenth at the end. Thousandths until then. All of these are going to be rounded. We're going to have stuff rounded to the thousandths. Okay? Number 5, we cannot find the area or the perimeter yet because we don't have our height. Remember, your height is your altitude from the vertex perpendicular. Okay, form that 90-degree angle. We don't have our height. We also don't have our third side over here, which will wind up being our hypotenuse. But let's find our height. Right here, we have a right triangle. If we know our triples, we know our 3, 4, 5 triple. If we don't, no problem. We're looking for our height. So our height squared plus the 3 squared will be 5 squared. I want you to pause and complete this Pythagorean theorem problem to get your answer. So now we've got the squared. We're going to go ahead and subtract that 9, and we're going to get h squared is 16. Square root it. H will equal 4. So our height is that 4. So we have a 3, 4, 5 triple. Now that we have our height, we can go find our area. Remembering our area now, triangle, base times height divided by 2. So our area ends up being that base of 15, the height of 4 divided by 2. And this is where you can go to the fraction function, just put 15 times 4 on top and 2 on bottom, press enter, and you got it all done in one step. Or go through the process here. I can go ahead and divide, see an even number up here. I can go ahead and simplify and go ahead and divide the 4 by 2, and this winds up being 15 times 2, which makes it a little bit easier because we could do that in our head. 15 times 2 is giving us 30. Now to find our perimeter, we have to find our hypotenuse of the actual triangle that we're finding the perimeter of. Okay, remember this 90 degrees over here as well. So we're going to find C. So here we have C squared is equal to our 4 squared plus our 15 squared. This is not a perfect, or this is not a triple, so we will wind up with a decimal. All right, go ahead, pause it, round to the nearest thousandth. Wind up with C squared is going to equal 241. When we square root this, round to the nearest thousandth, your C is going to be approximately 15 and 524 thousandths. So to find our perimeter, we're going to take the 4 plus the 15, all three sides. Noticing where these dashed lines are not part of the triangle, okay? Those are to help us find other things. The triangle is just the 4, the 15, and the new 15 and 524 thousandths. So we're going to add all those together. You can pause it and do it. You know you can. Now, round to the nearest tenth, we're going to wind up with 34.5. Make sure it doesn't look like a decimal there. Number 6, I encourage you to do this on your own. You only have to do Pythagorean theorem once, okay? Guys, please understand, we have our height. First semester, the very end, we learned about our special segments. You do sometimes have your altitude of a triangle drawn outside. You've seen this before, even before geometry class. Here's our 90 degrees. It's perpendicular with our triangle, so this is our height. So we can go ahead and find our area. Our area of our base times height divided by 2. Let's substitute in. Base is only going to be this 22. Okay, this dashed line does not count. All right, it's not part of the triangle. So we have 22 times our 16 height divided by 2. If you want to simplify the 2, you can only divide one of these. You cannot divide both of them. Okay, so if you want to simplify, we can now say 22 times 8, or just plug it all in the calculator. You do not have to simplify. Your area will come out to 176. Go use Pythagorean theorem to find the third side there, which will wind up being the hypotenuse of our triangle. Okay? Go do that on your own, round to the nearest thousandths. I'm going to very, very quickly go through it. So here, looking for the hypotenuse, C squared is equal to 8 squared plus 16 squared. We actually already did this one on the previous page. So your C squared is going to be equal to 64 plus 256. And we're going to add those together to get 320. Square root. Your C, your missing side, is going to be that 17 and 889 thousandths. So now we can find our perimeter with our three sides, the 34, the 22, and now the 17, 889 thousandths. I'm going to write that one first. Add them all together and get your perimeter. Pause it, add them, round to the nearest tenth. Your perimeter should come out to 73.9, 73 and 9/10. All right, on number 7, we need to notice here that we have an isosceles triangle. How do I know? Oh, the congruent sides. Your height, or your altitude in an isosceles triangle is going to act as all these special segments. It's also going to be an angle bisector. It's going to be a perpendicular bisector. It's going to be a median. So what ends up happening is going to split. It's going to bisect this base down here. Okay? But I do have my base and I do have my height. So I can go ahead and find my area. Go find your area. Pause it. Do it on your own. So we should have multiplied 24 times 28 and divided by 2. Or if we want to go ahead and simplify first, doesn't matter which one, but only one of them. And simplify this to 12 times 28. The divided by 2 is gone now. Your area, when you calculate it on your own, should have come out to 336. So we take a look over here. We're going to have to use our Pythagorean theorem using half of the triangle here. Okay? Doesn't matter which half you use. But we have our legs. Again, we happen to be looking for c again. So we're going to have c squared is equal to 24 squared plus 28 squared. Sorry, we do not have 24 squared. Here, we split this in half, so my key, I drew out the picture. We have 12 down here now, okay, and we have the 28 right here. We're looking for c. So we have 12 squared plus 28 squared. Now, if you wanted that shortcut I was talking about, if you don't like this, don't do it. Do your Pythagorean theorem like normal. You can go ahead and square root that entire thing, that's the entire part of the equation that's on the right. Square root of 12 squared plus 28 squared. If you plug it all in the calculator underneath that radical, you do it all in one step. And we're going to find out that our missing two sides comes out to approximately 30 and 463 thousandths. Remembering that we have two of these, okay? So to find our perimeter, we're going to need two of the 30 and 463 thousandths, both these sides, plus, we're going back to the 24 because it's the whole base. Multiply all of these together. I'm sorry, well, multiply these and then add it to the 24. Again, you could plug all this in one step. 2 times 30.463 plus the 24. Rounded to the nearest tenth, though, our final answer, we should get 84 and 9/10. The next problem may seem a little tricky when you read it, but we're going to walk all the way through this. We're going to have a base that is 4 times the height, and the area is 242 square millimeters. We want to find the base and the height. Well, we're going to have to find the height to find the base. Take a look at this. We're saying the base, little b, is 4 times the height, which is h. So that's what the base is. So, so you can see we have to find h to substitute in. So let's go find h. Our formula being area equals base times height divided by 2, let's substitute in what we know. Well, we know the area is 242. And what happens on the other side, let me move it down so I have a little bit more room. 242 is going to be equal to, well, we have something that we can't have these two different variables, but we do have something else we can substitute in for little b. We have 4h. So we're going to substitute in 4h, and then leave that other h there, all divided by 2. If you want, you could go ahead and work out this, the top and the numerator, and then you can use your proportions, or watch what else happens. You can go ahead and simplify this right here, 4 divided by 2. So we realize 242 is equal to, and that gets rid of the 2 on the bottom. 4 divided by 2 is now, instead of 4h, we have 2h times our other h. So now we need to multiply this. So we have 242 is equal to, well, our coefficients, it's like with our radicals, whole numbers are whole numbers, radicals are radicals. Here we're going to multiply our coefficients of 2 and that invisible 1 to 2. 2 times 1 is 2. H times h, just like x times x, just like 5 times 5. It's called squared. Okay, it's not 2h. 5 times 5 is not 25. Okay, so h times h is going to give us h squared. When solving backwards, we go PEMDAS backwards, which apparently they don't teach SADMEP anymore, but that's PEMDAS spelled backwards. So the exponent is actually going to be the last thing that we do. So, and we've seen this in class already. Let's divide both sides by that coefficient. And I'm going to go ahead and continue on over here. 242 divided by 2 is 121. all equal to, okay, this is gone, so all we have is at h squared. So, just like Pythagorean theorem, how do we get rid of that? We're going to square root. So h is going to come out to 11. Now we can go substitute in for our base. So we found our height. Now let's find our base. We're going to substitute in. Everybody should be able to do this one in their head. 11 times any single-digit number. Okay. And our base is going to come out to 44. So we found both of what we wanted.